Recently I got a sound card and I plan to upgrade to some decent studio monitors in the future. As I was looking at various accessories, I came across Woo meters. Instead of buying one, I decided to build my own instead, and after some digging, I found this kit on Aliexpress. It caught my attention because I really liked the style of the analog meters. The price was also very affordable. Without wasting any time, this is the finished product. On the front side there are the meters, and on the back the RCA connectors. It's powered by USB-C, and here is the power switch. Now I just need to connect the output of the sound card to the input of the unit, and the output of the unit to the speakers. Give it some power and turn it on. For the components, I got the kit I mentioned earlier. It includes analog meters, a PCB and connectors with wires. For the power supply, I got a USB-C panel mount extension cable. If you are going to get one as well, make sure that it's a USB 3.0 cable, because otherwise power delivery won't work. To get the higher voltage, I got a simple power delivery trigger board. The kit specified that a 12V supply was required, and that was what I was going for. But I soon realized that none of my power supplies can offer 12V. I tested the kit with 9V because my supply can do that, and everything worked flawlessly. I adjusted the output on the trigger board to 9V and power supply was done. The only thing left are the RCA connectors and the push button switch. You can find them both on Aliexpress. I'll put some links down below if you have trouble finding the parts yourself. That's it, those are all of the components, and now it's time to create the enclosure for it all. Since I have a few 3D printers, the obvious choice was to 3D print one. I didn't want to make a simple square box, so I took some time to create something more interesting. I was really happy with the enclosure after 3D modeling it, and after checking for clearances, I started the printers. It consists of 4 parts, everything is held with M3 inserts and M3 bolts, and I couldn't wait for it to be finished. The other day, the parts were printed. I took them off the printers and soon realized that the sides are all messed up. I was thinking of maybe sanding and painting the parts, but in the end I decided to print a simple TPU sleeve to cover it all. The sleeve is very flexible and not only looks good, but will provide some protection to the case if I ever drop it by a chance. For the build, I decided to clean up the case first, test everything and put all of the inserts in their holes. These inserts are really awesome, you just melt them into plastic with a soldering iron and they hold very tight. For the electronics, I wanted to connect the power supply first. It is the most complicated part of the build, so I wanted to be finished with it as soon as possible. The extension cable was too long, so I had to shorten it a bit. While writing the script, I totally forgot that when I do this, I'll have 24 wires to connect back together. I also needed the red VCC wire to connect it to the switch so I can turn on and off the device. This part took way too long, but eventually all of the wires were connected together and when I tested it, it worked. 9V on the output, exactly what I wanted. This 9V is going to be used to power the meter board and the light on the power switch. I put some electrical tape on the loose wires to protect them a bit. Then I connected the power connector from the kit to the output of the trigger board. To the switch I connected the incoming red VCC wire from the panel mount USB-C connector, and to the other terminal I connected the red wire that was going to the trigger board. I also connected the LED on the switch to the 9V supply. Then I screwed in the PCB and continued with connecting the RCA jacks. I tapped into both channels and ground with the provided connector from the kit. The only thing left to do was to solder the connectors to the meters. You can see how the meters are marked with a plus and a minus sign. Plus goes to red wire and minus to the black one. The outside terminals are for the LED backlight and the inside ones are for the needles. I attached the meters to the front panel with some M3 by 12mm bolts and M3 nuts. Now I just needed to connect 4 connectors to the board and test if it works. And it did. I screwed everything together and since everything worked, I put the TPU sleeve over the plastic case. I added some rubber feet and the meter was done. I hope you like the build. This is my first video and I really enjoyed making it. All of the parts are linked down below. The total cost was around 30 euros without the printed parts. I also uploaded the enclosure to Thingiverse so anyone can download the files and 3D print it at home. I have a few more projects planned and one of them is going to be a lab bench power supply, so if you want to see that, don't forget to subscribe.